Hello everybody, this is Gordon. We're going to begin our first module in physics. This is a 5-problem set in motion in a straight line. We have formula here. V represents velocity, S is distance, T is time. So we have velocities, A and acceleration. So we have relationships relating velocity, distance, and time, acceleration, velocity, and time, and finally distance, velocity, and time, and distance and acceleration. Our first problem, a ship travels 9 kilometers in 45 minutes. We're asked to find the speed of the ship in kilometers per hour. We're given time as 45 minutes. We can convert that into hours by multiplying it by 1 hour divided by 60 minutes. And we come up with a time of 45 over 60 hours. Take out the 15s and you get 3 over 4 hours, or 0.75 hours. Using the relationship V is equal to S divided by T, we have 9 kilometers divided by 0.75 hours, which gives us a velocity of 12 kilometers per hour. And that's the first problem. The second problem, the velocity of sound in air at sea level is approximately 1,100 feet per second. And it asks, if you hear a clap of thunder 3 seconds after seeing the lightning, how far away was the lightning? We're given V as 1,100 feet per second and T, time, as 3 seconds. We're asked to find S. And again, we can use the first relationship, the first formula. V is equal to S divided by T. We can rewrite that as S is equal to V times T. The velocity again, 1,100 feet per second. And the time, 3 seconds. Seconds in the numerator and denominator cancel out, of course. And our answer is 3,300 feet as the distance. The third problem gives the speed of light as approximately 3 times 10 to the 8th meters per second. It also gives the distance of the sun from the earth as 1.5 times 10 to the 11th meter, and asks how long does it take for light to reach the earth. We write down our given. V is equal to 3.8 meters per second. S equal to 1.5 times 10 to the 11th meters. Again, we're trying to find T. V is equal to S divided by T as given. We rewrite that as T is equal to S divided by V. Here, S, we have 1.5 times 10 to the 11th meters, and V, 3 times 10 to the 8th meters per second. That is equal to 15 times 10 to the 10th meters, to make life easy on ourselves. And then repeat 3 times 10 to the 8th meters per second. 15 divided by 3 times 10 to the 10 minus 8, using our powers of 10. Our answer, 5 times 10 squared seconds, 500 seconds, 8 minutes and 20 seconds. Our fourth problem, a car travels 270 kilometers in 4.5 hours. We're asked to find the average velocity, the distance the car will travel in 7 hours, and how long it takes for the car to cover 300 kilometers. So we're given S, the distance, 270 kilometers, the time, 4.5 hours. Excuse me. So the average velocity is equal to distance divided by time, 270 kilometers divided by 4.5 hours, which equals 60 kilometers per hour. Using that as a velocity, the distance traveled in 7 hours will equal 60 kilometers per hour times 7 hours, the given time. And we come up with a distance of 420 kilometers. The time to cover 300 kilometers will be the distance to be traveled divided by the velocity. So 300 kilometers divided by 60 kilometers per hour, and that will equal 5 hours. And that problem is done. Our last problem in the set: an airplane with a speed of 400 kilometers an hour experiences a tailwind of 120 kilometers per hour, and we're asked how long will it take for the plane to travel 1,000 kilometers. The idea here is that the speeds are additive. 400 kilometers is what the plane is doing, and is being pushed an additional 120 kilometers per hour. It's got a good tailwind, and so the total velocity is 400 kilometers per hour plus 120 kilometers per hour, which comes out to be 520 kilometers per hour as a velocity, or as a speed. And then using the first equation again, we're asked to find out how long it will take for the plane to travel 1,000 kilometers. Time will be distance divided by velocity. So it's 1,000 kilometers divided by 520 kilometers per hour. Time then is 1.9 hours. And that's our first set. Thank you.